Hey Wallace, it's Sunday. Sorry about that. You gave me math homework, and the math homework wasn't bad, but it was math homework that I was kind of lazy about. That's on me. I don't mind if you keep assigning math homework. So, Poincare-Bendix theorem. We have some interesting thoughts on continuous two-dimensional, not discrete. Is an important fact about that theorem, but continuous two-dimensional systems can't necessarily be unstable. Stochastic, if you will. Stochastic, I believe, is the right word. If you assume some things about them. As a computer scientist, I care a lot about discrete systems, but it's still a neat theorem. As for mathematical learnings on my end, I read an interesting post on r/math this morning of all the groups, if you enumerate all the groups of order less than 2,000, 99% of them have order exactly 1024. So you'll remember the order of the group, right? We talked in number theory about groups that are generated by prime numbers. Those are the generators of the group. And the order is just the number of times you can multiply by that generator until you wind back up at the generator itself in modulo that generator. That was a pretty bad explanation of this very specific case of groups. There are more groups. There are more ways to define a group than what we talked about in number theory. But the definition of the order is just like the cardinality of that group, which is something that was fairly defined in number theory. Anyway, 99% of them have order exactly 1024 if you look at all the groups order less than 2,000. And this is really interesting, and it turns out that for powers of 2, there are like a ton of groups that have order given by a power of 2. And what's interesting about it, if you read discussions about this online, at least on the Reddit thread I read, the Stack Overflow Math Overflow post it referenced, and another random blog post, is we have a lot of asymptotic bounds about how things play out in the discrete world, but no exact statements. And I think that's really interesting and also exciting as a scientist about how much we know and how much more work that can be done in terms of tightening bounds and whether we can exactly get formulas for certain things. In terms of interesting life updates, I can't say I have much. My period of sleeping on various people's couches will come to a close on Tuesday, a fact I'm very excited about. And I went to a lovely housewarming party yesterday. There are some stunning views from the rooftops of Seattle. I went to a very, very fun robotics colloquium on Friday that was held by my PI, where she invited people from a number of different departments on University of Washington's campus, including the aerospace engineer who I sent you a link about. Very, very cool stuff happening across multiple disciplines in the field of robotics, and it was cool to talk to certain people. I talked to this one guy who trained an agent to trained a robot to not quite play baseball, but he would lob things at the robot's head, and the robot would use a pool noodle to block the things, which he looked like he was having a lot of fun in the video demos. His arguments were interesting and awkwardly related to game theory. Specifically, he was these reinforcement learning agents are solving an optimization problem, and they're trying to reach a global minima of some cost function, and what winds up happening is every Nash equilibrium, every policy that's at a Nash equilibrium where you don't want to change the policy because you're going to affect kind of the reward coming out of this game, if you assume it's a zero-sum game. The ball throwing is a zero-sum game. If you train enough of these agents, one of them will be a Nash equilibrium, and we can try to look for these Nash equilibrium in policy space. So that was neat. A policy, as an addendum there, is just a function that maps whatever state you're in to an action that you should take next. So that was really cool. The colloquium in general was cool. It's just very interesting to talk to people about all the projects that are going on. It makes me excited to do my own work and kind of join this marketplace of ideas. That's all the updates I have for you. Best of luck with Strogatz. I know you've been working with that book for a long time. The day is really lovely today. I guess I'm going to ask you, how do you relax? You sound like you're doing a lot of math and a lot of work, and I know that you like to do things on your weekends like hike and stuff like that, which are great ways to relax, but sometimes you need to discharge at the end of the day, so it's 7 p.m. here. I've been reading papers all day and I kind of want to relax. So what do you do to kind of discharge at the end of a long day? My plan's probably going to be coffee and Duolingo. Or maybe, yeah, probably just going to go on Duolingo. Watch anime? Maybe watch anime. I don't know. It's a mystery. I've gone over 5 minutes, so I'll stop talking. I haven't yet to figure out what to do with the rest of my day. But I'm glad I finally got to check in with you. See you whenever you respond.